Hi, it's time for another math easy solution. Turn to discuss further into trigonometric integrals. Now go over example 5 on the example series. And now we'll go over this example, which is integral of 10 to the power of 6 of x times by secant to the power of 4. Now the integral, this is not straightforward, but from my earlier videos of doing integrals of sine and cos, we could apply a similar method. Yeah, and basically in my last video I covered the complete strategy on integrating functions in the form of something like this. Sine to the power of m times cos to the power of n, where m and n are just integers greater than or equal to 0. But for functions in the form of this right here, tan to the power of m times secant to the power of n, such as this 6 and 4, we can use a similar strategy. And we know that in this case, well, we know that the derivative of tan of x, which I showed in my earlier video, is just secant squared of x. Yeah, thus since we know this, we can separate a single secant squared term and convert the remaining, and will be even power of secant, to tangent using the formula right here, which is actually secant, or the identity secant squared equals 1 plus tan squared of x. And the reason we're doing this is the same thing as this is almost exactly the same as the strategy I used for sine and cos, because we're going to be separating this and then using substitution rule. Now this identity, this is from basically, well, we know the basic one, sine squared plus cos squared of x equals to 1. And if you were to divide this by cos squared of x, just divide everything out, then you would basically get this identity there. So you'll just get here tan squared of x plus 1 equals to secant squared of x. So that's just where we get this one from. Yeah, so basically, since we know this derivative, we could basically separate one secant squared of x and then convert the remaining into tan squared of x, and then apply substitution rule where u equals tan of x. Yeah, or since we know that the derivative of secant of x, this equals to secant x tan x, then we could basically separate this secant x tan x and then convert the remaining secant x into tan of x. And that's what I wrote right here. We could basically separate a single secant x tan x factor and convert the remaining, which it has to be even because we're using an even identity right here, squared. Power of tangent to secant by using, well, we're just going to rearrange the above formula. Tan squared equals 2 secant squared minus 1. So that's just this, and then moving this negative and moving this 1 to the left side. Yeah, so now that I've just went over a little brief summary of how we should go about solving the examples such as these, let's get back to our example. So basically the integral of tan 6 x secant 4 of x dx. We could basically, well, we see a secant 4, this is an even, they're both even. We could separate this, or write this as a secant squared. So we'll have it tan 6x times by secant squared of x times by secant squared of x. This is secant, not sine, secant squared dx right there. So now the reason we have this is because once we apply substitution rule, we can cancel these out. I'll get to that in a bit. So now we could apply the identity. So integral of tan 6x. Now convert this secant squared into tan. So that's just going to be 1 plus tan squared of x. And now this is going to be secant squared of x dx. And now we would apply our substitution rule. So let u equals 2 tan of x, and this is because the differential du is going to equal to secant squared x dx, which is this entire right side. So now we could apply this whole thing, and we get integral from tan 6x secant 4x dx equals 2 with the new substitution. u6 u to the power of 6 1 plus u squared times by du. So we've completely removed this. Now we're dealing with just one variable, u. And now we can multiply this inside, so we get integral of u to the 6 plus u to the 8 du. And now we get to solve for the integral. This would be u to the power of 7 divided by 7 plus 1 9, and this goes to 9. Now we always have to add a constant c, and now when we plug in back our u, which is tan, so we get 1 over 7 tan this power of 7 plus 1 over 9 tan power of 9 of x plus c, and there is our final answer. Yeah, and that was pretty straightforward on solving the integral of trig functions that are in the form of this. Anyways, that's all for today. Hope you learned from this this quick video and introduction on solving tan x times secant x type integrals. And in later videos I'll go over some more examples. Anyways, that's all for today. Hope you learned from this video. Like always, you can download these exact notes in the link below. And thanks for watching, and stay tuned for another Math Easy solution.